for today is conjectures. When we look at conjectures, we're going to be looking at inductive reasoning. When you use inductive reasoning, you're making a conclusion based on observations and patterns. A conjecture is simply a concluding statement reached by using inductive reasoning. So let's look at our first sequence. If we take a look at 38, 31, 24, 17, we're looking for a pattern. You're noticing that each number is decreasing by 7. So the next term would be 10, and then 3, and then -4, then -11, and -18. So the conjecture that we can form is to generate the next term, subtract 7 from the previous term. All right, let's look at the next one. 2, 5, 11, 23. So what we have to do is figure out what the pattern is. How do we generate the next 5 terms? You'll notice 2 times 2 is 4, plus 1 would be 5. 5 times 2 is 10, plus 1 would be 11. 11 times 2 is 22, plus 1 is 23. So our next term would be 47. We would double 23 and add 1. Double 47 and add 1 gives us 95. Double 95, add 1 gives us 191. Double 191, add 1 gives us 383. And double 383 and add 1 gives us 767. Conjecture. To generate the next term, double the previous term and add 1. Okay, we're going to take a look at this pattern. We have 1, 4, 9, 16. You should notice that each one of these is a perfect square. So the next perfect square in the sequence would be 25, 36, 49, 64, 81. Conjecture. Each term is a square. To find the nth term, square n. Now we're looking at our next sequence, A, D, G, J. You'll notice that we are skipping 2 letters after the previous letter. So 2 letters after J would be M. Skip 2 letters after M, you would get P. Skip 2 letters after P, you would get S. Skip 2 letters after S, you would get V. Skip 2 letters after V, and you would get Y. Conjecture. To generate the next term, skip 2 letters after the previous term. Now, when we're looking at conjectures, we have to determine whether a conjecture is true or false. If a conjecture is false, you are able to show a counter example. So a counter example simply shows that a conjecture is false. If you can't find a counterexample, then the conjecture is true. The product of two numbers is always larger than either number. We need to determine if this conjecture is true or false. So if we can figure out any two numbers that we could multiply in which their product is less than the numbers multiplied, that would be our counterexample. So for example, if I take 2 times 1/2, my answer is 1. Notice that the product of the two numbers is less than one of the numbers. And our conjecture says that the product of two numbers is always larger than either number. Okay, so let's take another one. 0 times 5 is 0. The product of 0 and 5 is 0, and 0 is not larger than either number. It is equal to 1, but not larger. So therefore, I have two counterexamples making this conjecture false. The sum of any two consecutive integers is always odd. So our consecutive integers, let's look at some examples. We would have 0 plus 1. 1 and 0 are consecutive integers, and that would give me 1. 1 plus 2, 1 and 2 are consecutive integers. That would give me 3. 2 plus 3, consecutive integers. That would give me 5. My pattern seems to show, and I can't think of another example where I have two consecutive integers that the sum would be anything but odd. So this conjecture is true. And now you've worked with conjectures.